You've gone through the migration process and are ready to move your first microservice to GKE. In today's episode, let's see how.
Let's consider the ice cream theory, which is an online ice cream parlor. They're on this journey to migrate their monolith website to microservices, and they're looking for guidance in moving their first microservice to GKE. So we'll walk them through the migration in stages.
Well, we'll need to run an assessment of their current environment to determine how many public endpoints we will need and what needs to move. But we'll get to that in the next episode. For now, let's assume that they have picked up a feature that makes sense to start with this migration.
Before we start converting their chosen feature to a microservice on GKE, let's see how to prepare their GCP environment.
Well, before they migrate the legacy components, they will need a place to put them. And for that, they will need a GCP organization.
Then they need to ensure that only people with the right authorization can access the resources. So they need to design GCP policies to control access to the GCP resources.
And once that's taken care of, it's time to create a plan to deploy the resources in a standardized, reproducible way using infrastructure as a code, utilizing tools like Deployment Manager and Terraform.
At this point, we recommend the ice cream theory team to study GKE and its features so that they can tweak them for their needs. This will mean changing some of GKE's defaults and maybe hardening the cluster security.
Once GKE is set up, it's time to build the CI/CD pipeline. They can use their existing tools like Spinnaker or Jenkins, or they can use the GCP products like Cloud Build and Container Registry to build, store, and scan those container images. Doing this early in the project will avoid problems when they are in production.
And remember the last episode where we discussed communication options between Google Cloud and on-premises data centers? Well, they would need to decide whether an API-based solution like Apigee or a private connection like Cloud Interconnect is better for their needs.
Now that we have our GCP environment set up, which is kind of like preheating the oven to start the actual cooking, it's time to start migrating the legacy platform over to GCP.
Overall, we recommend that Ice Cream Theory migrate their features of the website one by one to the new environment, creating microservices when required. Those microservices can call back to the legacy system whenever they need.
Migrating in stages like this has two advantages. Smaller projects are easier to work with, minimize errors and costly mistakes, and it lets you handle each individual migration without getting overwhelmed.
The first thing to analyze is the dependencies of the shopping cart feature on the rest of the system. We can do that by reasoning through the steps the user takes when interacting with the website. The user makes the ice cream selection and clicks Add to my shopping cart. That triggers an API call from the user's browser to the shopping cart. Once the shopping cart receives the call, it checks whether the chosen ice cream is in stock by making an API call to the inventory system. If the item is in stock, the shopping cart stores the info, something like Carter has one instance of item strawberry ice cream in the cart. Finally, when the user checks out and goes through the payment process, the shopping cart is queried by the payment subsystem to compute the total. And once the payment is complete, the payment subsystem notifies the shopping cart feature to empty the cart. So if we analyze this at a high level, this shopping cart feature has 4 dependencies. It is called by the front end and the payment subsystem, and it queries a database and the inventory system.
Now that we have identified the dependencies, let's give some thought to the choice of database for this feature. A document database is well suited for storing shopping carts, since shopping carts can be easily indexed by user IDs and you don't need the power of relational database here. Cloud Firestore is a great fit for this purpose. It's a managed and serverless NoSQL document database, so let's consider that for our target architecture.
Now comes the biggest piece, migrating the actual shopping cart feature. Assuming Ice Cream Theory can schedule a maintenance for their website.
Wait. I don't know when is downtime for ice creams. I know I can eat ice creams in the middle of the night.
I know. Well, let's assume that they can do scheduled maintenance. First, they would need to create a new microservice that can call the inventory system and uses Cloud Firestore to implement a shopping cart API. Then create a script that extracts shopping cart entries from the legacy shopping cart system and writes them to Cloud Firestore. This script needs to be written in a way that it can be rerun as many times as needed, but only copies the shopping carts that have been changed since last time. Then create a script that does the opposite, which is it copies shopping carts from Cloud Firestore back to the legacy subsystem in case they need to roll back the migration. Then expose the shopping cart API with Apigee.
They would need to prepare and test the modification to the front end and payment systems so they can call the new shopping cart system. Again comes the time to run the data migration script we prepared earlier so all the data is in sync and we did not lose any shopping cart records in the process.
At this point, they need to put their website in maintenance mode and rerun the data migration script. Deploy the tested modifications done to the front end and the payment system on the legacy production system. Once done, they're ready to disable the maintenance mode in the website.
And with that, the shopping cart feature of the Ice Cream Theory website is now microservice hosted on Google Cloud. The hardest step of this process is where they had to make changes to the legacy payment and front-end system. But that gets easier as they migrate more and more features to microservices because more and more of the dependencies will already be microservices. As such, they're more loosely coupled than in monolithic application and are easier to modify and deploy.
For more information about alternative migration approaches, check out the article written by Marco and Teo.
Well, there you have it. If you are looking to migrate a monolithic application to microservices, you've got a small taste of the steps involved through the Ice Cream Theory's use case. Stay tuned for the next episode where we will talk about deciding what to migrate first. Until then, try the end-to-end migration of an e-commerce website in the CodeLab link below.
That's all for today on Get Cooking in Cloud. If you like what we're cooking here and would like to see more recipes, don't forget to like and subscribe to our channel.